Hi there, in this video you're going to learn how to solve inequalities. Your objective for today is to learn how to solve inequalities by using addition and subtraction properties of inequality, and to solve inequalities by multiplying or dividing by a positive or negative number. Here's the first thing that you need to learn, addition and subtraction properties. When you add or subtract the same number from each side of an inequality, the inequality remains true. So it's the same thing, it's very similar with equations. So whatever you do to one side of the equation, you do to the other. Whatever you do to one side of the inequality, you do to the other, and the inequality here should remain the same. So if you have 5 is less than 9, 5 plus 4 should be less than 9 plus 4 because you're adding the same number, which is true. 9 is less than 13. And on this side, you have 11 is greater than 6. Well, let's see if you subtract the same number. Let's subtract 3 on both sides. You end up with 8 is greater than 3. So the way you solve an inequality with addition or subtraction is the same way that you would solve equations with addition or subtraction. So here we have x plus 5 is greater than 12. How would we get x by itself? Well, you would subtract both sides by 5, right? Because the opposite of adding 5 is minus 5. And then these 5s cancel out, and you're just left with x is greater than 7. So in order to check, now you would just plug in a number that is greater than 7 for x. So I'm going to use the number 10 just because that's an easy number to play around with. You could use 8, you could use 9, you could use 20. So I'm going to do 10 plus 5 is greater than 12. So once you solve it, you get 15 is greater than 12. Thank you. All right, graphing an inequality. When graphing inequalities, it is often easier to visualize the solution when the variable is on the left side of the inequality symbol. So notice that when you graph 6 is greater than x and x is less than 6, you get the same graph. You get, actually this should not even be a closed circle. That should be an open circle. So that is what I'm going to fix right now. Let's make this transparent. And, all right, perfect. So you have an open circle on the 6, and it's less than 6. So here, x could be 5, 4, 3, 2, 1. And here, x could be 5, 4, 3, 2, 1, etc. So that's why you have an open circle on the 6, and then it goes to the left, because it's all the numbers that are less than 6. That's what x could be. Okay, so don't just follow the inequality symbol because that's wrong. If you notice, this inequality symbol is facing the right, but the graph is going left. So don't follow that. You actually need to make sure that you read the inequality the way that it is. So if 6 is greater than x, then x has to be all the numbers that are less than 6. All right, here is another example. We have solve 3 is less than or equal to b minus 1 and 1/3. Graph the solution on a number line. So here we have minus 1 and 1/3. We have to undo that, so we're going to add 1 and 1/3 on both sides. On the left, we're left with 4 and 1/3 is less than or equal to b, or you could say b is greater than or equal to 4 and 1/3. These two are the same. I would prefer to read it like this, just so that the arrow would match the inequality symbol. That makes things a little bit easier, but it's up to you however you want to do it. Okay, so since the inequality symbol is greater than or equal to, draw a closed dot on the 4 and 1/3 with an arrow pointed to the right. Multiplying and dividing positives. So when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So here's an example. We have negative 6 is less than 10. If you do negative 6 times 2, 10 times 2, you get negative 12 is less than 20. This is correct. Same thing here. If you divide both sides of these by 4, 20 divided by 4, 16 divided by 4, you get 5 to be greater than 4. Okay, so you would just solve the same way that you would solve an equation here. So 7c plus 6 is less than or equal to 45. Here you would subtract both sides by 6, right? You would cancel these 6's out, and you would be left with 7c is less than or equal to 39. Now, how do you get c by itself? Well, you would divide both sides by 7, and then you would end up getting c to be less than 5 and 4/7, or you could do the decimal way. All right, here is the big difference between inequalities and equations. So when you multiply and divide by negatives, this changes the whole thing. So if you're multiplying or dividing both sides by the same negative number, you need to reverse the inequality symbol. So that means that here we have negative 4 is less than 5. So if you multiply both sides by negative 3, you have to flip that inequality symbol to greater than. Same thing here. You would need to flip. Here you're dividing both sides by a negative 3, so you need to flip the inequality symbol. Okay, here we have negative 5x is less than 45. How do we solve for x? We would divide both sides by negative 5, not negative 5x. You would divide both sides by negative 5, and you would get your x to be greater than 9. Notice here I just flipped the inequality symbol. And if you don't believe me, you can just check. So what's a number greater than 9? I'm going to use 10. Negative 5 times 10 is less than 45. And negative 5 times 10 is negative 50, is less than 45. Your answer checks out. Okay, here's one more example. I have b over negative 8 minus 2 is greater than or equal to negative 8. Add both sides by 2. Now here you would have to multiply each side by negative 8, right? These two would cancel out. And here you have b is less than or equal to 48. Okay, and then if you check with any number that's less than or equal to 48, like 16, you would get your check correct. So just your concluding thoughts, just make sure that when you multiply or divide by a negative number, you flip the inequality sign. Other than that, it's still equations. It's still the same thing as equations.